Previously, we have covered basic Python data types and coded a simple Fizz Buzz game. Data types define the kind of values that can be stored and manipulated within a program. Let us look into the Python data types in more details. In Python, there are 8 overall data types to describe texts, numerical numbers, sequences, mapping, sets, Boolean values, binary data, and the non-data type. We will focus on a few common ones in this table. First, Python is a dynamically typed language. There is no need to define the type of variables. Here, I assign the integer 10 to variable x, string 10 to variable y, and the dictionary to variable z with keys hydrogen and carbon. When checking using the type function, we see the type of each variable is different. We can enforce the data types in programming. In this Python code snippet, we see examples of enforcing data types using the float and complex functions. First, the variable x is assigned the integer value 5 and y is assigned the string hello world. Next, x is enforced to be a float using the float function, which converts the integer value 1 to a floating point number. We confirm the change in data type using the type function. Similarly, x is enforced to be a complex number using the complex function, converting the integer value 1 to a complex number. Again, we verify the data type using the type parenthesis function. By enforcing data types, we ensure that variables contain values of the expected types, helping to prevent errors and maintain the integrity of our programs. Arrays are a fundamental data structure in programming. A list in our daily life, such as a movie list to watch this month, can be something like matrix, Doom, matrix. It is ordered. We may want to reference elements of this list by saying that, let us watch the first movie in the movie list. It is changeable. We can add or change movies in the list. It allows duplicates. We can watch a movie twice. Similarly, lists in Python are an ordered collection of elements that can be of the same or different data types. We define a list using brackets in Python. For example, we can define a list to be bracket apple, banana, cherry. Another list to be 15793. And another to be true, false, false, etc. A list can contain different data types. We can say list 4 is ABC 34 true 40 matrix. We can print the length of a list with print len list 4, for example. We can index individual elements of the list. For example, list 1 bracket 0 returns the first element in the list, and list 1 bracket 1 returns the second element in this list. Because lists are changeable, we can modify their elements by directly assigning new values. For example, we can change list 1 bracket 0 to blueberry. In this way, we change the first element of this list to blueberry, from apple to blueberry. Now we print list 1 again, we see the list is updated. Another way to describe a collection of data in Python is a tuple. In math, a one tuple is called a monad. A two tuple is a pair. For example, the xy coordinate of Mount Rainier on a map is a two tuple. A 3-tuple is a triple. For example, the 3D coordinates of the peak of Mount Rainier is a 3-tuple. A 4-tuple is a quadruple. From these concepts, tuple in Python is a data collection that is ordered and allows duplicates. It is, however, unchangeable and immutable, meaning that its size and content are fixed once formed. Tuples in Python are defined by parentheses. We can contain all the previous list content in tuples like this. We can also access the individual elements and print, for example, tuple 1 bracket 0. However, if we try to change the element with, for example, tuple 1 bracket 0 equal blueberry, you see a type error appears because tuple is not changeable. Let us consider an example with lists and tuples to understand their differences. When we assign a list to another variable, both variables point to the same list in memory. So modifying the list through one variable also affects the other variable pointing to the same list. If we assign A to be a list of 102 and assign B to be equal to A, then they point to the same location in memory. So if we change A0 to be 10, B0 also is changed to 10. And printing A and B gives 10, 2, and 10, 2. However, with tuples, the story is different. Tuples are unchangeable. So when we assign a new tuple to a variable, it actually creates a new tuple in memory, breaking the reference to the previous tuple. If we change A to be a tuple in the previous snippet, assign B to be equal to A, then A and B are both 102 at this point. However, after executing A equals tuple 10, 2, a new tuple is created, but B remains 102. The output of printing A and B will be 10, 2, and 102. So, in summary, when dealing with lists, be aware that modifying the list through one variable affects other variables pointing to the same list. But with tuples, assigning a new tuple breaks the reference to the previous tuple since tuples are unchangeable. Be careful with this also in functions. If we have a function that changes the first element of a list x to 20, then after feeding a list 10, 11, 12 to this very simple function, because the variable name x is only a reference and points to the same location as LST in memory. When we print LST again, it gives 20, 11, and 12. The first element is changed. Another collection of data is the data type set. In mathematics, we have the concept of set. We would say, for example, 1 belongs to the set of integers z. Square root of 2 belongs to the set of real numbers r. These sets are unordered, unchangeable, and do not allow duplicates, different from list and tuple. A set in Python is analogously defined. A set is defined with braces. It is unordered, unchangeable, and allows no duplicates. For example, we can have similar contents from previous lists. We have set 1 to be apple, banana, cherry, set 2 to be 1, 5, 7, 9, 3, set 3 to be true, false, set 4 to be ABC, 34, true, 40, matrix. However, a set is unordered, So if we try to print set1 bracket 0, we see a type error. If we try to assign duplicates in a set, for example, set 5 to be equal to ABC 34 to 34 matrix and print set 5, we see that the duplicates only appear once. The last collection of data type we will cover today is the dictionary data type. A dictionary in life can contain things such as dune, will explain amount or rigid of sand or other loose sediment formed by the wind, especially on the seacoast or in the desert. And matrix will be explained, for example, as an environment or material in which something develops. A dictionary in Python, DICT, shares similar features. It is ordered, changeable, and does not allow duplicates. For example, we can define a dictionary saying car to be brand, model, and year to contain these three types of information. And we can say brand is Ford, model is Mustang, and year is 1964. With a dictionary, we can easily index elements without numbers. For example, we can get the brand of the car by calling car bracket brand. If we try to add a duplicate to the dictionary, let's say at the end we add brand and Ford in the last line of this dictionary, if we print it again, we see that the dictionary only contains one brand. Okay, we have talked a few more details about collection of data in Python. Here is a quick summary. We have list, tuple, set, and dictionary. List is ordered, changeable, and allows duplicates. A tuple is also ordered, but is not changeable, and it allows duplicates. A set is not ordered, unchangeable, and doesn't allow duplicates. A dictionary is ordered, changeable, but it doesn't allow duplicates. Finally, the non-data type represents the absence of a value. It is very useful in evaluating matches. Let us take a look using an example. In the code snippet here, we can use the match function in module re. We can check if letter A is in the string a tiger. The result is a success. The matched variable is set to none when there's no match found by the rematch function. For example, if we match Paul Atreides in the ME 480 student list, the result is none. We can then evaluate a if match is none condition, which checks if the value of matched is none before printing it doesn't match.